So once you get a good understanding of how the end behavior of a function affects the shape of its graph, one cool thing that you can use it for is making sketches of polynomials, especially polynomials that are given in intercept form. So for instance, if you have a polynomial, let's take for example f of x equals x plus 3 to the 7th power times x plus 2 times x minus 6 cubed, or to the 3rd power, we can make a pretty decent sketch of this graph. One of the first things that you want to do anytime you're trying to approximate a sketch is figure out what the zeros are. So in this case, we just look at what value of x would make any of these factors, any of these parentheses equal to 0. So if we plug in -3, for instance, here, this will become 0, -2, this will become 0, and 6, this will become 0. So our zeros are then -3, -2, and 6. From there, what we want to do is figure out what the degree and what the sign of the leading coefficient are. So the degree of the polynomial, you figure it out basically by looking at the powers on each factor, or on each 0. So on this factor, we have a power of 7. So that means -3 is a root of multiplicity 7. Here we don't have any power, but this is a root of multiplicity 1, okay? And then here we have the 3rd power, so this is a root of multiplicity 3. So we add up not the numbers that you see, but the multiplicities of all the roots. So we have 7, 1, and 3. So that means we have a degree. 7 plus 1 plus 3 is 11. Then we want to know the sign on the leading coefficient. Okay, and all you do to determine that is look at the first term in each of these factors. So we have x, x, and x. We multiply those together, we get x cubed. The coefficient on that is just 1, so the sign is positive, okay? You're not necessarily concerned with the actual value. You just want to know, is it positive or is it negative? Because the degree and that sign are the two things that influence the end behavior. So we have odd degree of 11, and a positive sign. That means that the end behavior of this function is exactly like the end behavior of y equals x. So to make a sketch, we lay out our axes here. The first thing that you want to do is plot the zeros. So we're going to have a 0 at -3, a 0 at -2, and finally a 0 at 6. And the end behavior, as you go towards -infinity, you're going toward -infinity on the y-axis as well. And as you go towards positive infinity, you're going towards positive infinity on the y-axis as well. So we don't know exactly what happens in between, but we do know that our line is going to pass through these 3 points. So we can kind of, and it's only going to pass through these 3 points. So what we can do is kind of approximate it. Maybe it goes up like that. Maybe it doesn't go up quite that much. It could do kind of anything in between here, and then it's going to come back through this point and go up like that. And to double check, to kind of see how close we are, we can plug this in to our graphing calculator, hit graph, and it gives us, doesn't look exactly like that. It goes down a little bit further here, and it's a little narrower up here, but a pretty good approximation just from looking at the zeros and the degree and the sign on the leading coefficient. So hopefully that gives you an idea of why you would care about end behavior and how it's useful in terms of sketching graphs.